Okay, so we left off with this intramembranous ossification. So here, again, we get this compact, very thin compact bone that sandwiches a lot of this spongy bone, and we convert the mesenchymal cells basically to osteoblasts, which give rise and get rid of all this, dense regular connective tissue, leaving only some fibrous periosteum, right, and bone. So we're good there. And again, remember that's the skull and the sternum and the clavicles. So endochondral, which is most of the way we ossify, means that we started with this cartilage template. And of course, if it's cartilage, we have a perichondrium, so not really a big deal. I'm not looking to, but that's the connective tissue around this and separating this. But this solid hyaline cartilage, right? So we have to begin replacing this nice, more flexible, soft, and not as supportive bone structure material to bone rock, right? So endochondral. We do have a few more cells to consider, and so please note that makes a great question for me on a test. So you basically start again around the week 12 or so of the fetus, and you start by this invasion of blood vessels into the middle area of the cartilage, bony. I'm just cartilage bone, all right? And so what has happened here again is as the cartilage has grown, it has, and cartilage is basically avascular itself. As it's grown, you started to see some deposition of calcium in the cartilage, and the chondrocytes have actually been dying. So again, everything had started with mesenchymal cells because that's just a very generic stem cell. That then became chondrocytes. All right, so you have all these chondrocytes in here instead of talking about osteogenic cells at this point, right? So chondrocytes. Chondrocytes in the middle grow, and they basically, over time, and not a long time, begin to calcify. So they accumulate calcium. The calcium kills them. All right, so it kills the cells, and the cartilage is not maintained. Right, so blood vessels begin to migrate into this space left by these dying cells, and bring osteogenic cells. All right, so again, and the osteogenic cells become osteoblasts. So in the blood vessels invade into this center. Again, remember this is going to be the diaphysis, so this is what we also call the primary ossification center. This is where it begins. All right, the perichondrium is transformed to a periosteum. Not you see that transition here from here to here. This allows us to produce more bone because, again, underneath the connective tissue, periosteum, we find active osteoblasts as well. Right? So this walks through the whole thing, but we're going to take a couple slides to do this. Right? So, or actually, we're going to overview here. We're going to see we've gone from this cartilage, solid cartilage, to a space. Blood vessels have invaded. The blood vessels, space is going to remain here as a medullary cavity full of a lot of blood, but we're going to start to see this conversion of the cartilage into bone here. All right. Now, a little while later, we're going to get a secondary ossification center. All right, in the epiphyses. What's to be the epiphyses? So see how this has remained cartilage at this point, and we see again this calcification of the cartilage cells here, and they die. Right. And as they die, then the osteoblasts begin to invade in there, right? And you'll see blood vessels, right, grow into the center here, and we'll see a secondary ossification center happen. And between the two ossification centers would be the epiphyseal plate, this area where cartilage cells would remain alive. So on this slide, we kind of look at this area where the cartilage cells are remaining alive between the diaphysis and the epiphysis. So on the epiphyseal side, the cartilage continues to form. All right, so here we're looking again, this is our growth plates. And here's our metaphysis, right, this area between epiphysis and diaphysis that would be down here. All right, so you've got the cartilage forming on the epiphyseal side. the diaphyseal side, the cartilage is actually ossified. So here we don't see the actual diaphysis in this cartoon, but just beneath here we've got this, right, osseous tissue growing upwards, right? So when we look, and here's where we want to put our attention here. Here in the epiphyses, we would see a reserve zone, all right, which would be chondrocytes that aren't very active. So here they are around here. We'd have a proliferative zone, so they're lined up and they're actively dividing, all right? And they are replacing dead cells, which are basically down here. So that's why the bone can continue growing this way, and of course it's happening at the other end too, so bone is growing upwards and downwards if you look at this femur here, all right? So in this zone, right, we have this hypertrophic, which means they enlarge, and they're maturing. So these are older, right, cartilage cells, and they're probably really, and they're accumulating some calcium, and they're dying. Well, that calcium can be used, as well as the lipids and glycogen, by osteoblasts to help produce bone, right? And the osteoblasts that get surrounded will be converted to osteocytes as they continue on. Of course, I said towards the diaphysis you have this calcified zone, and that's where you have mostly dead chondrocytes, and osteoblasts are just coming into this area, right? The cartilage cells are being destroyed and recycled, and the osteoblasts are building new bone tissue, all right? Bones grow wider and longer, so here that was the lengthening in that epiphyseal plate, but they also can grow wide, and that's called appositional growth, all right? So here again, reinforcing that chondrocytes allow for the lengthening of the bone, but they don't last. They hypertrophy, calcify, and die. That was the point of the last one. So you will continue to get taller as long as there's chondrocytes. There's a reserve, right? And they're there. But at some point, and this is triggered by hormones, they will all die, and you will not be able to grow any taller. Osteoblasts are the builders, right? And they'll deposit bone in the place of those calcified cartilage, right? So as we said, here in the calcified matrix that osteoblasts invade. This process continues until the centers meet and the epiphyseal line plate becomes a line, right? So appositional growth is when we add diameter, and bone can continue to do this throughout your life. So these osteoclasts, which are really crazy cells, remember they came from monocytes and macrophages, and it says here again, they have many nuclei, and the monocytes actually fuse together to form these cells. And so these osteoclasts, they're destroyers. They secrete an acid substance to dissolve the matrix, right? This calcium phosphate that we call hydroxyapatite. And that, right, they destroy it to dissolve matrix that lines the medullary cavity. So they're really very active on that, you know, right underneath that endosteum. The osteoblasts beneath the periosteum then build new. So that's why I said you have this growing outwards while you're dissolving inwards. So the ratio of compact bone is not really changing, right? So this ratio of that to the soft tissues, the marrow. All right? So bone remodels throughout its life. So it's not going to continue to grow long, but appositional growth and remodeling occur throughout your life. And they do this according to your need, right? And your demands, all right? So think of it that way. So some of the needs are calcium-based, but also the demands can be, you know, the use of that bone, and especially the muscle attached to the bone. So here's two femurs. One of these femurs is used by someone who's very, very active, and especially since this is the it's a posterior view of the femur. These are areas where the gluteal muscles, especially the gluteus maximus, attaches. All right, and that's a powerful extender of the entire thigh, and the whole lower limb. So this person is much thicker, denser bone, than this person. Well, this bone has grown according to the demand or need that the person had on the bone. So I say here this homeostasis, right, so maintaining balance and meeting your needs, right, happens throughout life, adult life. So again, you stop getting longer, but you can continue to get denser. Osteoclasts, right, remove existing bone, and osteoblasts deposit new. And as we saw, the osteoclasts, they live under the endosteum or close to the endosteum, osteoblasts under the periosteum. And here, again, most of the surfaces, when in growth to change the shapes of bones, and in repair and calcium regulation. So again, hopefully you haven't had to repair your bone, but if you did, this would also be true here. I've talked and will continue to speak about calcium regulation in the blood and the demands you have on the muscles that attach. Now, bone growth is influenced, of course, by nutrition. I have this in your group questions, right? You can't build new tissue if you don't have the basic ingredients to make this, right? So bone needs calcium, and calcium absorption needs vitamin D, and so these are strong components. They're not exclusive components, but they're very important. Your exposure to sunlight, this of course is because this enhances the conversion of precursor chemicals of vitamin D to active vitamin D. So exposure to sunlight assists them, right, because you activate vitamin D this way. And then hormonal secretions and exercise. And exercise is a huge influence. So hormonal secretions, here we're really talking about what we call the anabolic hormones, the steroid hormones, right? Estrogen, testosterone, progesterone, all right? Now here's an example of bone repair, right? I said you're not going to be tested on the types of fractures, so that would you know clinically, but you don't have to know from me, right? It is, like I said, it is a good thing to know though clinically. Here's the idea. Again, you rupture a bone, and in this case, you completely separated the diaphysis, all right? And you know, of course, you seal off and try to stop the blood loss immediately, because remember, bone has a lot of blood, all right? So clotting process reduces blood flow into the injury. Osteocytes die from the injury and the exposure to chemicals released by injured cells. Chondrocytes, so we kind of reverse back here, right? We go back to our chondrocytes from the endosteum, the inner part of there, secrete a new, right, fibrous, so collagen, cartilage kind of matrix. And this is called a callus. So it's kind of like a scar at this point, but it's a temporary scar, or temporary band-aid, if you will. The external callus is from periosteal chondrocytes, right? So, and osteoblasts, all right? But what you're doing again is you're trying to allow the bone to still be used while you're in the process of building new bone. So that's what the callus serves for, right? Osteoclasts become active and dissolve the dead bone. Osteogenic cells produce more osteoblasts, and in time, generally we generally say, depending on, you know, about 6 weeks, you will basically rebuild that lost tissue. All right? Factors affecting the bone, you do need to know these. And I've mentioned these on that slide before the last one, that you have vitamins, minerals, and exercise are the huge influences. So vitamin A, right, helps osteoblasts and osteoclasts to function. So it prevent, you know, if you have a deficiency in vitamin A, you would have a problem with bone development. Vitamin C is collagen. I always think C for collagen. And without collagen, bone is not flexible. So it actually becomes somewhat fragile. I know that sounds weird because you're thinking, okay, it's a rock. But it becomes fragile to the physics of movement, right? The torsions, all right? Vitamin D allows us to absorb calcium, and without it, we get rickets, osteomalacia. And vitamin K, right, supports this mineralization, this conversion of calcium and phosphorus into osseous tissue, and might help assist with vitamin D. The minerals, I think, again, calcium is probably obvious. Magnesium, we said this is one of the things that we store in bone. It helps us with the structure of bone, maintaining, again, this order to our matrix. And fluoride stabilizes and strengthens bones, and it can help with our density of bone, right? Exercise all around stimulates bone growth. And we want a weight-bearing exercise on this. This is why machines like treadmills and ellipticals are not quite as good as just getting out there and walking or running. Biking does not stimulate bone growth. You don't get the same. It's not the same stress and strain that really comes from weight-bearing exercise. This is really important in trying to get denser bones. All right. And again, it's all about adapting to your needs. All right. The effect of hormones on bones. And you should know these, right? We've got pituitary hormones, thyroid, parathyroid, ovaries, and testes. And so the ovaries and testes are the sex hormones I mentioned already. But growth hormone comes from the anterior pituitary, and it helps chondrocytes, right, divide in those epiphyseal plates. It stimulates the osteoblasts, and it helps us retain calcium. Thyroxine promotes the osteoblasts, right, the builders, and also assists growth hormone, and parathyroid hormone stimulates osteoclasts.